So we want to do some of our review here of our law sines, law cosine stuff while we go over this. So I want to look at number 4, especially the one with the 2 answers. So on this one, it just said determine how many solutions are possible. A few people like worked out, spend time working out a whole bunch of stuff. You have to. It just says determine how many solutions are possible. Now, if the only way you know how to do that is to work it through and see if you have to do whatever, that takes a little more time, but you can do that. There's just 1 point for each of those. You either had it or you didn't have it. So what we talked about is that hanger, you know, swinger, the swinger leg here. Spring break. This leg, is it long enough, right? And if it's greater than this one over here, then you're just going to have one triangle. If it's less than, then you got to check and see, well, is it too small? Maybe there's not any. And so the way to do that is that height. We talked about that a little bit yesterday. That was that B sine A. You take 14 times sine of 45, and it's 9.89. And so what that means is, yeah, it is long enough to hit over here, and then it would swing over and hit over here as well. Because straight up and down is 9.89. So it'd be over here, and then it would swing over and make a second triangle there. On this one, when you try B or 30 times sine 52, it's 23.6. So that means it's 23.6 down to here, the height, and this 19 is just too short. That 19 would not reach that side over there. So there are no triangles, okay? So that's how we set it up. We always put our angle in this left corner, and then the side across, which would be, this would be angle B, this would be side B, and then the other side we put up here, okay? And anytime we have an SSA situation, if we write it like that, then that's going to be what we want, okay? To tell us if there's 2 or none. And again, if this side is longer than this side, there's only going to be 1. If this is an obtuse angle here, there can only be 1 or none. And the key is if this swinger leg is smaller, then there's not going to be any. If it's larger, then there's just going to be 1. Okay. Again, it's too small. There is no height when you have an obtuse. You don't have to worry about that. Okay. And then number 3 was worth 3 points because there was just 1 triangle, so you got a point for each one of these. If you did kind of set it up right, and for whatever reason didn't get a right answer, maybe I still only took off 2. But if you just didn't have it set up right anyway, I mean, you should get at least 1 right answer if you set it up correctly. So it's hard to imagine. So you might have lost 3 points if you didn't get any of that. But those are the different parts of that one. I want to go through number 4 here, kind of with you, just to make sure those are the answers for number 4. And we'll go through that one together. That was commonly missed, or maybe most commonly missed there. Number 5, as you walk on a level horizontal path toward a mountain, to measure the angle of elevation of the peak is 33. So that would be this right here. From a point 1,000 feet closer, so you move 1,000 feet closer, now the angle of elevation is 35. How high is the mountain? So this would be the mountain right here. So when you draw that, if this is 35, that'd be 145 right there. So it'd be good to find this measure. And once you find this measure, you can use this right triangle to find x. So we've got 33 and 145. That would add up to 178. That would leave you 2 for this angle right here, which to make 180. So the sine of 2 over 1,000 would equal the sine of 33 over y. Now, you could find this side over here, but there's no need to. It doesn't. Well, I guess it could, but the problem is you don't know this. And so then I just think finding this hypotenuse isn't really worthwhile. You could find this, and then you could find this, and then you could find this down here, and finally find this. But that's a lot of work that you don't need to do. So anyway, this is y. This is this side right here, and then you can do sine. Now you just do sine is opposite over hypotenuse. So sine of 35 would be x over that number, and then you get x to be that. Okay, so 3 points, kind of your setup, your picture, your answer. Number 6, 2 houses are separated by a lake. Gave you the picture, so it was all pretty much there. It's just pretty much a straightforward law of cosines, side angle side. So x squared equals all that, and then you don't forget to square root it at the end, and you get that right there. Okay, all right, back side. And we'll come back again. We'll come back and do number 4 here in a minute. On this side, find the missing part. I just did that just to speed things up a little bit so we had time to finish it. So this is all three sides are known, so you use the little half sheet you got to use. And again, you can use that again tomorrow on the quiz. Just comes out to 40.1. Here you find the missing part. This is a side angle side situation, so doing it that way, using that version of the law of cosines, gives you that. So those were 2 points each. And then 3 points for this triangle. This is a side angle side, so law of cosines to find this missing one over here, 13.4. Again, it's pretty good not to round. Some of you got off on decimal places, several decimal places, and that's because you rounded to 13.4. Okay, so you might have lost 1 point there on that. So when you put it into your equation over here, putting in this whole number here, or quite a few of those decimal places, does make a difference. Okay, it can make a difference of several tenths on your, and when your answer is supposed to be accurate to the nearest tenth, you know, if you're off a couple of tenths, then that's not good. Okay, so that's where that could have came into play. And then the flagpole one, again, I gave you the picture, so how far apart the two flagpoles, and so those are just a couple of law signs setups there. Okay, we did pretty good on that one. All right, so I'll give you some more problems that you can, some of them are even, so you might want to take some pictures out of the book here, because I won't be here in the morning, so, because our track meeting got moved, but you might want to take pictures of some of the answers here in the answer book, so you can work on those, but we're not going to add anything new today, so it should be ready to go. So let's take a look at the number 4 here. All right, so here were some strategies. These are things you had in your notes before. You know, if it's angle side or angle side angle, we're using law of sines. If it's SSA, we're using law of sines, but remember, that's the one that could have more triangles. If it's side angle, we use law of cosines. And we said finding the biggest angle is the way to go there. If you notice back here on this one where I had SSS like this, I didn't even do that. No, because we just had to find angle A, so that was okay, so it didn't matter. But if I was, going to solve the whole thing, then I might want to do this part right here. I might want to find the biggest one first, because if it's obtuse, that will give it to me. So that was a strategy that we talked about using. If it's side angle side, you're just going to use law of cosines, the normal law of cosines to find that third side. And then from there, you can just keep using law of cosines to find the biggest angle or find all the rest of the stuff, because law of cosines, like we said, isn't going to steer you wrong. The only reason you'd want to use law of cosines here to find the biggest angle is if you were then going to use law of sines later on, okay, because it's a little quicker. But if you're going to use law of cosines for every step of the way, it'll never steer you wrong. Law of cosines will never give you a bad answer, okay? So when you get down to here, if you use law of cosines to find the third side and then use law of cosines to find the rest of the missing step, you're fine. But if you're going to use law of sines, use it to find the smallest angle, because if you accidentally are using law of sines for the biggest angle and it's obtuse, it won't give you obtuse. Remember, law of sines is only going to give you quadrant 1 or 4, which it's negative, which it won't be. So it's only going to give you quadrant 1. So if you're using law of cosines, it's almost safest to just keep using law of cosines in the problem. Okay? All right, so let's look at number 4. So number 4 on the front of the quiz would have started out like this. So when you draw your picture, you get these numbers of just like the first problems where we were checking to see if we had how many solutions we had. We do B times sine A, B times sine A, right? This number times sine of this number, and that's 8.99. So that tells us that this would be 8.99. So that means if this is 8.99 straight down, we could have 11 going this way, or we could swing it around and we could have 11 going this way. Okay, so that could be 11 as well right there. All right, so when we do our law of sines to find our angle B, it comes out to be 54.9. Well, if that's 54.9 right there, that means this could be 54.9. It's an isosceles triangle, so this angle you have to subtract from 180. So that's where the 125.1 comes in. So if you didn't have a second triangle, maybe you weren't even checking, right? But when you notice it's an SSA situation, you should check, okay? And so once you know there's a second triangle, that means as soon as you find that first missing angle, this one over here, then right away, just subtract that from 180. Okay, now the reason you don't have to draw this picture. The reason you subtract it from 180 is when you swing this other side over here, and this is 54.9, the angle you're looking for in this triangle. This is your second triangle right here. Right? Your first triangle is the big blue one. Right? Your first triangle is this one. Your second triangle is that red one. Because it's got 14, it's got 11, it's got 40. It's got the same pieces of information. Okay, so this angle you're looking for in the red one is going to be the 125.1. Right there. All right, well, once you have 54.9, you know this one is 4. You got 54.9 here. Now you add those up, subtract from 180, get 85.1. Okay, on this one, if it's 125.1 right in here, if this is 125.1, you got this plus 125.1, subtract from 180, you got 14.9. So now you got all the angles. So now all you're looking for is this missing side here. So in the red one here, you would do, I did sine of 40 over 11. That 11 right there, sine of 40 over 11. And then I did, this angle was 14.9 up here, this little one. So sine of 14.9 over C. I got 4.4. On this one, I did 85 point. This is the 85.1 up here over C. I had 17.1. Okay, so that's how we do the two triangles. All right, take that first angle you get, subtract from 180, and then find the rest from there. All right, any other questions that I haven't covered here or that you want to ask me about earlier in the quiz on any of the other problems? Okay, all right, well, let's pass those back up. If you have an individual question about something, you know, and when we have some work time today, you can ask me, and I'll be glad to go over it with you, because if there is something, because a big part of tomorrow's is going to be this. You know, why are we doing another quiz? Well, it's kind of the end of the chapter, even though we didn't do a lot in this chapter. We just added one new thing. And so, like I told you yesterday, I'm hoping it's a grade enhancement opportunity. Noah, we just went over the quiz. That's all you missed. And you saw your score already. Yeah. Okay. So I'm looking at that as a grade enhancement opportunity tomorrow. All right. So if you need help in enhancing your grade, then be asking me some questions, right? Today when we have some work time, if you want me to go through some of those with you, and let me help you on it. Okay. All right. So worksheet questions. Larry, you probably need one. Good. There you go. Let's see, who else was going to miss? Okay.
Number 9 on the area of the triangle side.
Number 9. Which side?
Area of triangle.
This side. Number 9. Find the area of a regular pentagon with dimensions shown in figure 2. Okay? So, what would you know about these triangles? They're all the same. So if we can find the area of one, we can find the area of the whole thing by just multiplying by 5. Okay, so what piece of information, but it feels like we don't have quite enough. We only have 2 things. So what can we do? And to get the area, we're going to need more than that. We've got our area formulas, right? We've got our area formulas here. Well, I don't have them up right now, but you know. Okay, we got our area formula. So what could we find here? Right here, don't we know those 2 are equal? Those 2 are going to be equal. Because it's a regular pentagon, all of these are going to be equal here. Right? The regular pentagon means there's symmetry all over the place. equal angles, all that stuff. So 180 minus 72 is 108, which means each of these is going to be 54. And if you want to call that x, whatever, on that side right there. So we could do sine of 54 over x equals sine of 72 over 10, right? And what do we get for x then? 8.5065, something like that. Yeah, I mean, it would be good to carry out a few decimal places because anytime we're going to use these sides, now 8.5, since it's 8.50, there's a fair bet if we just rounded this to 8.5, we'd be okay. But again, where we got in trouble on the homework or on the quiz on that one, if it's 8.54 and we round it to 8.5, that extra amount could really matter. But having that 0 in there probably helps a little bit, but I would use that. Okay, so now, if that's x right now, now I got a side angle side that I could do my area, my one area formula. I could just go 1/2 times 10 times 8.5065 times sine of 54, right? That would be one of my area formulas. Or I know this is 8.5065, this is 8.5065, so now I got all three sides I can do Heron's formula, right? But I think if I could use this formula, I think I'd rather. I think it's just simpler to type in. You don't have as much stuff to do with the square root and everything. You don't have to remember that S is the semi-perimeter, so you got to remember to divide by 2. Some of us were forgetting that yesterday. So I just think this is a pretty good formula to get. So whatever that answer is, then we just multiply that by 5, right? And I don't know, did I have an answer key out here for this worksheet? I don't know if I did. I've got one here somewhere. Okay, so 172, is that exact? 172.05, 0.1. Okay, so I didn't make this key. So yeah, I think if it doesn't say, I think nearest tenth is good. Or did it say? I don't think it did say. So okay, all right, Charlie, good enough. All right. What else? What else? What else? Like I said, I do have the areas, or I do have the answers here to most of these. If you want to double check, when we have some more time for.
So, like 8 and 9 on the other side. I got most of it done. I just kind of stuck. Didn't know where to keep going.
Over here.
Yeah.
Yeah, so, okay, so it says the vertex A to side BC. So if I'm going to draw an altitude, I'm going to probably want to put A up here, right? I mean, it's just easier. You don't have to do that. It doesn't matter. But then B and C down here. So the altitude down to here, it's just easier to draw. So if I'm going to draw the vertex from A to BC, I would do that. So side A would be 15, side B 17 over here, and side C 24. So this was kind of that B side sine A thing we were talking about here. So to be able to find this height, we need one of these angles over here. And then we would have a kind of a right triangle situation, and we could figure that out. So we're trying to find H. So the key is we need one of those angles. So what would get one of those angles for us? Law of cosines, right? Law of cosine. So let's say I want an angle B. So law of cosine says cosine of B, right, would equal 15 squared plus 24 squared minus 17 squared. Isn't that how that works? All over Help me out, I forgot. 2 times. 2 times 15 times 24, right? We only use, so if we're doing cosine of b, this would be a squared plus c squared minus b squared, and this would be 2 times a times c, right? Like that. And so what do we get for angle b? Okay, and with angles, you're probably okay most of the time to round that because we're then going to do the sine and the cosine of those, and then those decimals aren't off all that much. So if this is 44.7, then don't we have enough to find h? It's opposite over hypotenuse, so now we know the sine of 44.7 would equal h over 24, right? Sine is opposite over hypotenuse, so sine of 44.7 is that. Now that did say to the nearest whole unit, so then you can just round that. And then on this one, you're just going to find these 2 areas. So when we'll have a review problem for this, but and we can talk about it if you want to here. But you're just going to add up those 2 triangle areas is your total area, and then you're going to divide by this amount, right? So take your total area, get that total area, divide by this many square feet. Oh shoot! I was going to go around and check worksheets. How many people didn't do their worksheet? Okay, good job. All right, so we got the total. We got the total amount. I guess so. I don't have to mark that down 100% for everybody. All right. Yes.
Can I see what you had for the answer for that one?
For which one?
Number 10.
Number 10? Yeah. 10. Okay. 10. I've got. I'm assuming Mrs. Payne did this right. Now again, it could be a rounding thing here. So she's got 2 different answers. Now, again, I would say if you didn't round. So somebody want to say their answer for number 10?
$342,537.46. I had 32.
I had $30.32.
You know what?
One of her answers is $342,530.32. Did you carry out?
Yeah, I just
No, you have to do.
Oh my gosh, I
divided by 43,000.
You're off by half. No. What'd you say?
500
and what?
537
and divided by that.
Oh, yeah. With $342,000, maybe $7 isn't that much.
Yeah, I got 342,000.
Well, then another answer, she has 340,909.09. That's if she rounded something. It looks like the 0.44 or something. If you need, so this side, what'd you have for this area here? You have it written down. What'd you have for this top area here?
5,775.4 something.
That's the key. Is how far out you go here. Okay. So. And then this one is
9,250.
That's where you went off there.
Yeah, I had 9,300.
This is 9,300.
285,933.
285. Now, make sure on the quiz, so like Noah, you said you did a lot on your calculator, which is fine. I mean, which means you save those decimals or store them or whatever. Use the answer button. Or write them down, but do that, write those numbers down on your paper. When you get one of those important numbers, like for example, the area of this, the area for this, and you write that down, because that just helps me for partial credit if I can see what you did, okay? If I can see what numbers you have, it's just a greater chance that I'm going to say, okay, you're good to here, you knew what you're doing here, that, whatever. So now when you add those up and divide by this number, and then multiply that by 150,000.
You have to divide 150,000 because you get a decimal, and then when you divide 150,000.
Oh, yeah, I'm sorry.
I divided
The
by
part, okay, yeah, what, they want the cost per acre, not total cost. Right, right. So you're gonna get, yes, so you're gonna have to take 150,000 divided by that answer that you get, how many acres you have. Yeah, they want the cost per acre, so you're gonna have to take the 150,000 divided by the acres. Okay, so you take this many square feet, where you add these up, you divide by 43,560, that's how many acres you have. Again, keep that, and then that must have been, is that number like 0.4? Do you have that written down? You take this, these two added together, divide by this, it's like 0.43, something, 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 something. Okay, and then you take 150,000 divided by that number. Okay, now, again, I think if you're concerned with the rounding, which you definitely would be on this problem, because you got a lot of dividing and a lot of calculated values you're using, I would make sure to write them out. If I'm doing this on a quiz, I'd make sure to write out those decimals and show what I'm doing. Now, would I give a little bit of leeway maybe on a few pennies on one like this? For sure. $7? No, that would be out. That's definite rounding error. Okay? I know. All right. Okay, so back to here. Okay, so here's a problem we're going to do here in a minute. But before we do that, let me just review what we talked about yesterday. So we have what I have up here. You don't have to write this down. You don't have to write this part down, but we will work out that problem here in a minute. So if you've got these three area formulas. Okay, so we've reviewed the law and sines and cosines. Hopefully we're pretty good with that, but we'll have some review time after lunch. We pretty much all worked out. And I've got a worksheet with a few area problems, and I've got some book problems you can do as review for law, sines, cosines, a little bit of everything. But we got our basic geometry area formula. We got the two new ones that we learned here. Okay, all I want to do with this page is you tell me which one would be the most appropriate one to use. Now, you could do a variety of things. I mean, I get the answer could be you could use any of them. If you found enough information using law, sines, law, cosines, other stuff. But which one could you most directly just use the area, which area formula to find the area? So what about this one? Number 2 would just get it to you right away. Side angle side, you got the included angle, the two sides. That's perfect for that, for number 2. Okay, what about this one? Number 3, you got side, side, side. Then you can use Huron's formula to get that. Okay, what about this one?
Number 1.
This would be number 1. This would be a basic geometry problem. You got a base, you got a height, off you go, right? Just 1/2 base times height, easy. Okay, what about that one? Not the most directly. 3 would work for sure.
But can you use 2?
Well, but you don't have an angle, so you can't use 2. Not without getting some more information. What do you know about 3, 4, 5? 3, 4, 5 is a Pythagorean triple. So where's the right angle? Right angle's right here. So this would be a base, this would be a height. So you could just do 1/2, 3 times 4, just be 6, right? It's a little bit of a trick question, and I'm not going to necessarily do that to you on the quiz tomorrow. But the idea is, not necessarily, but the idea is just to recognize what you need for the different formulas. So an angle included in between, side angle side, that's what you really are looking for here. Side, side, side is Huron's formula. If you have a right angle, if you have a base and a height, then that's when this would work. And then, so the trick one was that there actually is a base and a height there because there is a right angle. But not a big deal. If I give you this problem on the quiz, say find the area, and you use Huron's formula, that'll be fun. Okay, that'll be fun. Okay. All right. So we're going to do this problem right here. So go ahead and think about this. Read this. Think about this with a partner if you want. Would be good to discuss with a partner. Probably will take about 10 minutes here or so to 5 minutes to let you think about it. They're going to build a triangular enclosure for the dog with 3 pieces of fencing. Okay. Let's try it.
I hope it's a small dog. So. What's up, cutie?
So,
Because first of all, that's none of your business, like, none of this is your business if you just start to have
And it does give you bigger.
like, still,
but like, it does.
this guy's crazy. Because we're running low.
I mean, that's seriously the same one.
I mean, I'm not trying I do my Excels. That's old right there.
7,
That's gonna be raising up.
5, 6.
No, the dog is not good there.
Go with the 12. That's the only answer.
Because I probably
My time's 2.
Or 12 minus 10.
Oh
my god, it is.
Feet here.
How?
I don't know, 24 days.
Because if you do a 10, it's more narrow, but if you do a 10, what? Oh, I get it. Okay.
So we just have to decide whether it's 12
Hey Charlie,
Nice doghouse signs.
So like the 12-foot piece is more like 6 feet has been flatter to reach all the way next to. Sure.
so you need more.
And then if you do it with the math.
Make sure you tell me why.
Well, I did the
Say
areas.
something fun. Venus. He's a comedian.
What up?
Thanks.
I need you to buy this for me.
I have the most consistent remarks. If you would have choked, I would have killed you. Like, that being said, it was my fault that I died. I was playing terrible at the end. But if you would have choked, I probably would have shed actual tears.
They do this together all the time. And we got to the last 4 points. They killed us.
What?
Oh, sorry.
He fell down and tried to kill us. He got it. I ran over there and just shot at 2 people. And I was like, what? He turned around, shot me, his friend hit me, I killed him. He ran upstairs, saw him, and killed him, and we won.
Okay, what are you saying, Don?
Roll around the
Oh, no, I can't.
Which is 10. Yeah. Why?
Well, common sense or math?
Common sense or math? Common sense would tell me the bigger, the more fencing you have, the bigger area you can enclose. Would that make sense?
Do you want the math answer or the answer we came up with in our heads? I didn't.
Let me see what you come up with in your head. Huh?
Barry.
Once area.
Alright, well, if it's a 10-footer, it'll be like, more even and wider, so the enclosure will be.
It'll be as narrow as it'll be.
Yeah, it won't be as narrow.
So if you had this,
Makes a right triangle.
Well, okay, wait.
so if you have 6 and 8 here, you're gonna have to spread that open more to fit the 12-footer.
And so then you're gonna have, it's
And so it's gonna be narrower. So if this kept getting bigger and bigger,
It's just gonna get
you're, that's triangle. But if this got longer, if this gets longer and longer and longer, these are almost straight, right? And then that third piece is gonna be narrower and skinnier. So having the other side get longer doesn't necessarily make it. Now, I heard somebody say this is a right angle, it actually is. 6, 8, 10, just like 3, 4, 5, is a right angle. And so this would be a hypotenuse. And so what would you have here? You would have a height. So if you're gonna do the area, I mean, a quick look then at the area, now you can calculate it, obviously. I mean, you can just calculate it. But why, right? That's the idea. And so I like what you said about the narrow. Here you just have this base with a height of 8, right? If this hypotenuse gets longer, where it's not even a hypotenuse anymore, you still have a base of 6, but what's happening to your height? It's smaller than 8, right? And the longer this side gets, the smaller the height gets with the same base. You would still have a base of 6, and the height would be getting smaller and smaller and smaller, so therefore less area. Okay, and the same thing's true if that's why a right angle would be the best. If it wasn't a right angle, if this was smaller, say 8, maybe you had 6, 8, and 8. Now that hypotenuse again is less than 8. So your height. So you'd have 6 for the base, and you'd have something less than 8. So think of this as a side that could swing right here. This would be 6, this would be 8, but you don't know what this is. So when it's over here, that's a less area. As it goes this way, you get more and more area until you get here. And then as you go this way, you start getting less and less area. So right here's the max. That's actually a calculus thing, finding the max of situations like that are changing, right? Smaller and smaller area. And then you're getting bigger and bigger, and then starting to get smaller and smaller, right? And where's that spot where it would be the max? Okay, all right. So anyway, let's spend some time working together on this. You can just work with a partner on this. This is just some area problems, and then when we come back from lunch, or I'll actually. Take one. Everybody take one. Each person take one. And now, okay. Now, I don't know if you get this done before lunch, I'll have some book problems that I'll put up here that you can start to work on, and then we'll work on that after lunch. And again, come up, get help if you've got some questions. I don't know if I have any. I know this says quiz, but it's not. It's a practice. Practice. Let me see if I have answers for this. Oh, I also have some IXLs to add to the list. Now tomorrow, so the quiz, so they've changed the girls' track meet, I know, to tomorrow. So I won't be here. So Mrs. Payne will be here again. We'll do the quiz before lunch. And then after lunch will be work time mostly on these IXLs. Okay, that's what you'll have work time for. So I'm adding to the list here. Okay.
gotta make sure, like if you had all three sides, you take one half, and each sheet is 59.4.
The one that goes with
That's right. Otherwise. Oh. Right.
The answers to this are set up here if you want to double check.
Oh, so it's because the way you do it, you have to find this way, you have to find CU. I just found this angle. That's not CU. I thought that was great. Yeah, this is 38. Where'd you see it? See. Yeah, that, I think, if you did that, that's for something, if you do that.
Oh, no. Yeah.
All right, hang on here just a second before we get going here. All right, so okay. So, pay attention. All right, now, so quiz tomorrow. So basically, many of the same things that were on it before. On the other one, we throw in the area, solving a triangle, being able to tell how many solutions. Obviously, that only really affects a side angle situation, right? And when it's how many solutions there are. I mean, I'm not sure if there is one in this problem. I'm not sure. I'm not going to do that to you. If you have a side situation, it is possible that no such triangle exists. Remember the triangle inequality, any two sides of a triangle have to add up to be more than the third side in the triangle. So it's possible you could be given a side problem where there would not be a triangle that would have those numbers. Okay, but I'm not going to give you that scenario unless it was very obvious, unless it was, where I gave you a side and it literally asked you, is it possible that this is a triangle? Okay, well, again, chances are if you do the law of cosines with it, you would see that it wouldn't work, but you would know for sure that would have to do with triangle inequality kind of thing. But otherwise, if I just give you a triangle with three sides, say solve it, you can assume that that's a law of cosines and you just do it. Okay, some story problems potentially. And then that top one is it law of sines or law of cosines? We did some of that yesterday where I asked you, I said, okay, what would you use? It's an angle, side. Well, that's law of sines. Side, angle, side, that's law of cosines. So there might be a few like that you would do. And then I'm probably going to put one on as a bonus just because in case there's a time crunch. We're going to do the same thing. You have to do it before lunch. Now, I will tell Mrs. Payne that if if you're pressed for time and you want to use 5 minutes of your lunch to finish, on the last problem, but it's got to be done before you go to lunch. Okay, now that doesn't mean you get 5 extra minutes at the end of lunch, though, right? So if you want to use a little bit, you can do that. But otherwise, you'll have to be finished by that time. Okay, all right. Rest of the time you can use to work on these, and then your assignment to work on after lunch tomorrow will be these IXLs. Okay, and these pertain to triangles, so it would probably be good to try to get them done, not have to be doing them last minute. These IXLs will probably be done, or probably be due, I don't know, a few weeks from now, 3 weeks from now, maybe 2.5, 3 weeks.